Section 11.5, Day 1, Measures of Central Tendency and Variation. The essential question: how do I find the mean, median, and mode, and use box and whisker plots? Please write that down. Who uses this? Statisticians can use measures of central tendency and variation to analyze World Series results. Recall that the measures of central tendency values describe the center of a data set: mean, median, mode. Let's review what this represents. Mean, represents an average. So mean is going to be the sum of the values in a set divided by the number of values. Another way to write that is like that, X with a bar over it. Median is the middle of set, or it's going to be the mean of two values if there two of them are in the middle. And mode means most often. A data set may have one mode, no mode, or several modes. Example 1, find the mean, median, and mode of the data, talking about deer at a feeder each hour. First thing I like to do is I like to put everything in order from smallest to largest, because for median, we have to do it that way. So 0 and 0, let's do those. They're 1, 2, 2, 3, 4. Then that's done. So to find the mean, we're just going to add everything together and divide by the total number. 1, 2, 3, 4, 5, 6, 7. And when we do that, we get 12 over 7, which is 1.7 deer. So how many deer at a feeder each hour? On average is about 1.7 deer. Well, really can't have 0.7 of a deer, but there's more than one. Median. Well, let's do this. 0, 0, 1, 2, 2. That looks like a 22, so let's fix that. And we start on the outside and cross, and cross, and cross, and cross, and cross, and we get one middle. The median is 2. Mode is the one that occurs most often. Well, the 0 occurs twice and the 2 occurs twice. That is the mode. Example 2, a weighted average is a mean calculated by using frequencies of data values. Suppose that 30 movies are rated as follows. So 8 movies have a 4-star rating, 12 have a 3-star, 7 have a 2-star, 2 have a 1-star, and 1 movie has no stars at all. Find a weighted average. How do we find a weighted average? We take the number of movies, which is 8, and weight them with their rating. 12, 3, 7, 2 stars, 2, 1 star, and 1, no stars. All divided by the total number of movies. 8 plus 12 plus 7 plus 2 plus 1. When I do that, I get 84 over 30, which is 2.8 stars. That's how we find a weighted average. That's also a mean, but instead of up here just adding them all together and dividing by the number, we have to weight each of the movies by their rating and then divide by the number of movies. For numerical data, the weighted average of all of those outcomes is called the expected value for that experiment. The probability distribution for an experiment is the function that pairs each outcome with its probability. So this is another kind now. The probability distribution of successful free throws for a practice set is given below. Find the expected number of successes for one set. Remember, expected value, weighted average is an expected value. When you are given the number of outcomes and the probability of those outcomes, this is a scenario where you're going to take the number of outcomes times its probability. And so forth all the way. When I do that, I get 0 plus 3 over 20 plus 2 over 5 plus 3 over 2. And if I didn't have a calculator and I needed to do this by hand, I would get a common denominator, which is going to be 8 over 20 because I multiplied by 4 over 4. And here I multiplied by 10 over 10. And when we add those together, 3 plus the 8 and the 30, we get 41 over 20, which is 2.05. That is the expected number of successes. I want to compare that quickly to example 2. That also was a weighted average, but it was different because all we were given is the number of movies and their rating, not the probability of it happening. So in that case, we did have to take the number of movies times its rating, all of them, and then divide by the total number of movies. Here, it's different. When you're given the number of successes, in this case, good free throws, and you're given the probability of that happening, all you have to do is take the number times its probability. We're not going to then divide by the number again because that's kind of defeating the purpose of finding a weighted average. If you're given the probability of that occurrence happening, take the number times its probability and add them all together. Example 4 we're going to do in class, and now we're going to jump to box and whisker plots. A box and whisker plot shows the spread of a data set. It displays 5 key points: the minimum, the maximum, the median, middle, and then the first quartile and third quartile. So what the first quartile and the third quartile is going to be, I'm going to go through an example and explain how they are calculated. Minimum, obviously the lowest number. Maximum, the highest. And we already know how to find median. But we have to go over how do you find the first quartile and the third quartile. And then the interquartile range is taking quartile 3 minus quartile 1. I did not, that does not look like a 1. There we go. The quartiles are the medians of the lower and upper halves of the data set. And I will explain that to you. And so that's exactly what's happening here. We know what the median is of the entire data set, but quartile 1 is the median of the lower half. Quartile 3 is the median of the upper half. If there are an odd number of data values, you do not include the median in either half. And I already talked about the interquartile range. And basically, it's quartile 3 minus quartile 1, and it represents the middle 50% of the data. Let's do example 5. We are going to make a box and whisker plot of the data. First thing we should do is put the numbers in order from smallest to largest for sure. 4. There's a 5. There's a 6. There's another 6. There's a 7 and an 8 and another 8 and a 9. Perfect. Then I check 1, 2, 3, 4, 5. Oh, I checked because I forgot the 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. All right, let's scroll down a little bit here. And we're going to draw our box and whisker plot similar to what we had. So we have a minimum, and then we drew a line, and then we had our box. Median is in the middle. Okay. So what we're going to find here, obviously, this is going to be the minimum. This is going to be the max. This is going to be the median. This one's going to be quartile 1, and this one's going to be quartile 3. All right. Well, obviously, we know that the minimum is 4, and we know that the maximum is 10. Let's find the median. And there it is. So the median is 7. So now we have to find quartile 1 and quartile 3. So how do we do that? Well, I want to go back for just a minute. Okay, that's not what I wanted to look at. All right, so here's the deal. 1, 2, 3, 4, 5, 6, 7, 8. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is what I wanted to talk about. Okay. So right here it says, if there are an odd number of data values, do not include the median in either half. There's the median. There's an odd number of numbers. So when I'm finding quartile 1, I'm only going to look at these 4 numbers. Quartile 3, I'm going to look at these 4 numbers. I am not including the median in the calculation of finding Q1 or Q3. So now the median of, I'm going to just go like this, 4, 5, 6, and 6. There's 2 medians. So then the median is the average of the 2, which is going to be 5.5. Over here, we have 8, 8, 9, and 10. Same thing. There's 2 middles. So the median is going to be the average, which is 8.5. And the interquartile range is going to be 8.5 minus 5.5, which is going to be equal to 3. So these are all of the 5 numbers on a box and whisker plot. And recall again, let's go back to here. Scroll down. Never mind. I wanted to go here. The box and whisker plot shows the spread of a data set, how spread out your data is. All right, 6 is for class and video questions. Please do these in your notes.